Hello everyone. Today we have a circle geometry question from the Year 10 syllabus. As usual, I'd like you all to give it a try before we have a look at which theorems we'll need to complete the question. Alright, for those of you who are stuck on it, here are the theorems that we're going to need. Angle in the alternate segment. So that one looks at where we have a tangent and a chord. And you can see in our question that we've got a tangent and two chords coming off the tangent. And the other theorem that we'll use is the alternate angles on parallel lines. So we have parallel lines, so that gave us a clue about that one. All right, give it a try now if you were stuck before. All right. Now I'm going to go through it from beginning to end. So the first thing I tend to do with these kinds of questions, so it's a proof, so I want to label which two angles I'm trying to show are equal. So we'll have a look. It's angle ABP. So ABP. We've got this angle here, and it's the two smaller angles combined into one, and the angle ACB. So it's this angle in here. And as you can see, as soon as we label the angles, we can see that it's not a one-step process. It's not one theorem that we know that equates these two angles. So let's have a look. We can use our theorems, or we can think from the beginning. If we have, for instance, this angle here, now, which angles would it be equal to? Now, when I was at school, they referred to this as the windsurfer theorem because it's actually upside down today. We've got like a little windsurfer shape here. If you think about someone windsurfing, got that kind of shape happening. And the theorem goes that this angle is equal to this angle, and this angle is equal to this angle here. All right, so let's apply that in the diagram above. We've got that one angle, and that would be equal to this angle here. So we've got those two angles being equal. Now we have this clue about the parallel lines that I've already provided. Or we could take a look and see that we've got one line here and this other line here, the two parallel lines. So this angle would be equal to this angle here. And that solves our whole question. So let's write it out step by step. We can start with the left-hand side. Left-hand side equals angle ABP, which equals, so ABP was this one here, and we said using the orange stripes that it's equal to this one here. So angle, we don't have enough details for that angle, so I'm going to put in an extra angle, an extra point here to help me answer the question. Angle DAB, and that's by the alternate angles on parallel lines. So number 2, I'll just write there, and that refers to our theorems on the right. All right, so we've got angle DAB, and that one we said was equal to this one by our windsurfer theorem, or angle in the alternate segment. So that's a 1. So equals angle ACB according to theorem 1. And that is our right-hand side. So it's quite straightforward if you know your theorems and you're happy to brainstorm which angles are equal to which other angles. Of course, here you got the filtered version because I knew where the question was going. But if you brainstorm all the angles that you know are equal or supplementary or complementary, then you can build up this diagram of knowledge on your diagram until you find that you've labeled the two angles you're trying to prove are equal, and from there find the path that you took to get there. All right, have a great day, and I'll see you in the next one.